All right, here is our test review for the solving quadratics lesson. In this first problem, it says find the roots by factoring. So pay attention that you're doing the method specified. You won't get full credit if you use a different method, even if you get the right answer. So factoring is another way of talking about the cross method for this situation. We're going to start by what multiplies to AC and adds to B. A is 2, C is 21, so that's going to be 42, and then B is 17. So two numbers that multiply to 42 and add to 17. You might have a hard time with this because you would want to try probably like 6 and 7, but that doesn't work. So just do some scratch work and just start trying out things, right? 2, 21, 3 goes in 14 times, and so that will work right there. So 3 and 14. Because this is not 1, we have to split the middle term and do grouping. So I'm going to rewrite 17b as 3b and 14b. Right, so 3b, 14b. Do my grouping. The first group has a GCF of b. The second group has a GCF of 7. Now we look at both groups together. Their common factor is the 2b plus 3. And what's left is the b plus 7. So then remember our zero factor property, which says to take those individual factors and set them equal to 0. So I solved this first equation by subtracting 3 to both sides and then dividing by 2. And the other equation I solved by subtracting 7. Did I say b here? Subtracting 3 to both sides. Here I subtract 7. So my answers are -7 and -3/2. Number 2 says to use the quadratic formula. So first you want to have it set equal to 0. Then be sure you're in standard form, and now figure out your A, B, and C. A is 3, B is -4, C is -1. So plugging that in, I have negative B, so that's -4, plus or minus the square root of B squared minus 4, that 4 is from the formula, times A, C, all over 2A. So my next step, I like to do this negative B part and make that +4. I like to do the bottom. 2 times 3 is 6. And then for the math inside the radical, you have to follow your order of operations. So exponents first. -4 squared means -4 times -4, which is +16. And then I have -4 times 3 minus times -1. So do that left to right. So -4 times 3 is -12. Bring down the -1. Now this is a multiplication. -12 times -1 is +12. So I'm going to bring that back up here with the 16. 16 plus 12 is 28. So that is what is inside my radical. And then the next step, I'm going to simplify the radical by doing a quick factor tree. 4 times 7. Square root of 4 is 2. Bring it out front. And now I have 4 plus or minus 2 radical 7 over 6. And these three things, 4, 2, and 6, all have a 2 in common. So I divide that out of each one. And I'm left with 2 plus or minus 1 rad 7 over 3. And you don't have to keep this 1 here if you don't want to. So you cannot have that one, and it could just be implied. The next two problems are square root property. I'm going to start with this one first. Remember, the point of the square root property is to get this by itself so that you can square root both sides. So I'm going to start by dividing off the 3. So I have w plus 5 quantity squared equals 9. Now, I saw a lot of people today trying to FOIL or write this as w plus 5 squared. That's not wrong, but this particular property doesn't work like that. This is a convenient property when you can write it like this, because instead of, you can avoid the FOILing by square rooting both sides right here. So the square root cancels out the square. I have w plus 5 equals plus or minus 3. So now I subtract 5 to both sides. So w equals plus or minus 3 minus 5. Now, if this 5 had a radical, I would stop because I couldn't do any more math. But it doesn't. It's an integer. So I can write this in the positive form, positive 3 minus 5, and the negative form, negative 3 minus 5. And the positive 3 minus 5 gives me negative 2. Negative 3 minus 5 is negative 8. So there are my two answers for that problem. Now let's do this other square root property over here. This one is set up the same, only now there's an addition or subtraction on the right-hand side of the parentheses. So we're going to take care of that first by doing the opposite to both sides. So I'm here. Now divide by 2. Now square root both sides. So t minus 9 equals plus or minus the square root of 75. And I'm going to factor 75. So this is not a perfect square, so I need to factor and simplify. I'm going to factor into 3 times 25 because 25 is a perfect square. The square root of that is 5. And you're going to bring it right out front the radical, not in front of the plus or minus. It goes in front of the radical right here. So I have t minus 9 equals plus or minus 5 square roots of 3. And I still need to get t by itself, so I will add this 9 to both sides. And t equals, you can write this two different ways. You can write plus or minus 5 square roots of 3 plus 9, or 9 plus or minus 5 square roots of 3. You can even break this up into 9 plus 5 rad 3, 9 minus 5 rad 3. Any of those forms are acceptable. So on the back. So this first one is our product of consecutive integers problem. So you will have a calculator for this on the test. We talked about how we are going to call the first integer x, and how do you get from an integer to the next even integer or the next odd integer? You skip 2. So if the first one is x, the second one is going to be x plus 2. And the problem says that the product of those two things is 224. So to set up my equation, it would be the product of them. The first integer is x, the second integer is x plus 2, and that is going to equal 224. And I'm okay with you leaving your equation in this form. If you wanted to, you could distribute your x and move your 224 and put it in standard form, but I'm okay. This is accurate, and it didn't specify either way. Now, the next part, what are the two integers? Here's where I solve the equation that I wrote. So I'm going to start by distributing the x. That gives me x squared plus 2x equals 224. Now, before I can solve, I need to get it set equal to 0, so I'm going to subtract the 224 to both sides. So now I'm at x squared plus 2x minus 224 equals 0. You can try to factor this. You can do quadratic formula. I'm going to try and factor. Now, I already know what the answer is because I made the key earlier, but I want to model for you how you could try to factor when the number's really big and you have to do a lot of guessing and checking. What I would do is just make a factor tree. Like, 2 is going to go in 112 times. 2 is going to go into that 56 times. 56 is 8 times 7. And now once I get here, so 2 times 2 times 8 times 7 is 224. So I just start playing around with the numbers. Like, 2 times 2 is 4. 8 times 7 is 56. Will that give me 2? No. But I'd notice that 2 times 8 is 16, and 2 times 7 is 14. So these two numbers will be 16, and this 2 and this 7 is 14. And now I realize if this was negative, then these two numbers would multiply to negative 224 and add to 2. So that's how I find my two numbers. But also, if you don't like all that guessing and checking and factoring, you can just do quadratic formula, and that will work for you also. So I have x plus 16 times x minus 14 equals 0. So then setting those equal to 0 individually and solving gives me negative 16 and positive 14. And when I go back to the original problem, it says I'm specifically looking for negative even integers. So that rules out positive 14. So that means I have only one answer to this problem, x equals negative 16. But that's just my first integer. We defined x as the first integer. And we define the second integer as whatever x is plus 2. So if my first integer is negative 16, and I add 2, I get negative 14. So the numbers are negative 14 and negative 16. They are negative, they're even, they're consecutive, and they multiply to positive 224. All right, so I'm going to pause here, and I'm going to make a new video for the next two problems.